Hello everyone, this is Megha Ramesh. I'll be explaining part B of assignment 2, design and analysis of reconfigurable systems. In this, the only difference with respect to the previous video is that instead of doing 4 MSB LEDs, we will be doing 10 MSB LEDs for an LED counter on our FPGA Cyclone V board. For the second part, we open a new project and we open a new Verilog file. It is almost the same code as before, but the only changes is that the registers is 9 to 0 now instead of 3 to 0 because it's 10 bits, 10 MSB bits. Then since we need 10 for displaying 10 MSB, we need to use 31 is to 22 here. We can use the same LED test bench here, and after compiling it, I have already run the simulation. The simulation results are as follows. So there is an up counter from 0 to 10 here, and then it starts counting downwards. That is a down counter. As soon as the switch is changed, the direction is changed here. So after that, I also added the STC file and compiled it again. That is done as well. Now we'll go to assignment pin planner. So here our outputs are more than what we had previously. There are 10 outputs, 10 LEDs here. So we have to look into the data sheet again and assign the pins for the rest of the new LEDs and make sure it is right next to each other. We can verify it with the data sheet. Then after this gets closed and we'll have to go save it here in the IO assignment analysis. Compile this so the assignment of pins gets saved. It's getting compiled now. After the compilation of the assignments, we click on Program Devices, Open Programmer. Since we have already connected the FPGA to our laptop, the hardware setup already shows the selected hardware. And then we do auto detect again to make sure our device is connected here. And then we click on Start. So it got prototyped successfully 100% to the FPGA. We can check the outputs now. After programming the device, this is how the counting starts for down counter for a 10-bit MSB. So when we start resetting, it starts from the beginning, and then we can also change it to up counter here. And when up counter is there, when you click on reset, it starts from 0, 1, 2, 3. So the delay is very less between the counting here compared to the 4 MSB. Now that the desired output is already obtained on our FPGA, we'll have to flash it into our FPGA now. So to flash it, we click on File, Convert Programming Files. Then here we click on JTAG Indirect Configuration File. The configuration device, we click on our Cyclone 5 and EPCS 128. Okay. Then active serial, and here we save it as LED counter 10, and then we do preserve data. We add file. So for SOF, we add LED counter SOF, add flash loader, we add device, we click on Cyclone 5 here, then we do 5C, Sigma 5, okay, and then we generate a .gic file. The .gic file is generated successfully, okay, we close this, then we go to tools, programmer, then now and programmer, these two are already recognized. We double click here, then we add the LED counter 10 output file, okay. And now we check on this gets checked, and we start. It takes time to flash this, so it has to reach up to 100%. It's getting flashed slowly now.
After flashing the device, we remove the USB plastic connection. We power off the device. Now again we power on. The switch is down. So the down counting starts. When you press reset, starts from the beginning. Then you do this and press this. Reset. We switched it and pressed reset, so up counting started from the beginning. And when you press reset again, it starts here. And when it's counting in between, and when you switch, it starts down counting as well. So the device has been flashed successfully.
The final part of this circuit is to find the critical path. Before finding the critical path, we'll have to compile the entire thing again because we have new files generated. And then we go to tools, timing analyzer, then we click on read path. Then we just click on report path, and the delay is 6.645. That's from node pre-count 28 to node count 6.